Hey everyone, this is Daniel, and you're about to watch a long-form conversation with Haoyi Li. He's a software engineer and a core contributor to the Scala ecosystem, and he's built a whole suite of Scala libraries focusing on productivity and simplicity under the Haoyi banner, as well as the Mill build tool, which he has since expanded beyond Scala to support other programming languages like Java and Kotlin with experimental support for things like TypeScript or even Android. And Mill promises better performance and user friendliness than things like Gradle and Maven can ever hope to match. He's also the author of the book Hands-on Scala Programming, which focuses on getting things done with Scala, which I've also used as a jumping off inspiration point for my own course on Scala Projects. And you can find that on Rock the JVM. And we talk about a lot of things. We talk about Mill, about the Scala ecosystem, and where Scala still fares better than other languages, about productivity, about some AI and how he uses AI, his own work and open source process, and more. So please enjoy a wide-ranging conversation with Haoyi Li. Haoyi, it's good to see you. Thanks for making the time.
Sure. Yeah, it's great to see you too, Daniel.
So I wanted to talk about a bunch of things about your contributions, about Mill, of course. But what I wanted to start with was something that I found fascinating when I first heard about it, which is that you went on a conference tour of sorts, and I think you're still doing it, if I'm not mistaken. Can you tell us more about it, what prompted the decision, and why this particular form of marketing?
Sure. So, I guess the baseline is I left my last job last year, so I'm on sabbatical now for a year or plus or so. And in this sabbatical, I've been taking time to do all the things I wanted to do that I couldn't do, and I spend my days working. So one of which is my open source projects. So and open source work is more than just coding and throwing something online. You want people to use it. If no one uses your stuff, then you don't get feedback. You don't know how to improve it. And without this kind of like flywheel of feedback and improvements, your projects tend to get stuck. So now that I have more time on sabbatical, I figured that I wanted to try and see how far I could push some of these open source projects. One of them is the Mill build tool. So Mill is interesting because I think not only can people in the Scala community use it, but other JVM languages like Java, like Kotlin, they have their build tools like Maven or Gradle, but I think there's probably room for something new and maybe better. So as part of this, I decided that if I want to try to get people to use it, I need to go and tell people about it. And that's what I've been doing the last few trips overseas. So I've been going to conferences, meetups. Anyone who is interested in hearing me talk about JVM build tools, I'll go and give them a pitch and see if they're interested. And hopefully I'll get some users and maybe even some contributors from this.
How many conferences and meetups have you gone to so far?
45 this
Okay.
year.
Not
Yeah.
wow,
So
just this year. So this is
this
what I
year,
found
yes.
fascinating because when I saw like open source releases or frameworks or libraries or things like that, the authors just went on like one or two conferences, like the big ones. They made an announcement and that was it. But you're going like overseas to anyone who's willing to hear you speak. I'm wondering what prompted the decision to do this particular form of getting your tool in front of people instead of doing the probably now traditional, I don't know, LinkedIn posts or social media or that kind of thing.
I guess it's all of the above. So I am doing LinkedIn posts, I am doing social media, but as you know, like trying to get the new project out into the wild, into people's hands is quite difficult. So especially, the community is big, it's diverse. Many people don't spend their lives on social media, but so if you want to try and reach these people, then how do you do so? Like obviously you can't reach everyone, but there will be people that go to in-person conferences and in-person meetups. Some of these people will be paying more attention to you standing in front of them talking than they would to some post on Twitter or Hacker News. Um, and so I have managed to get a bunch of posts to go viral on Hacker News or Twitter or Reddit, but I don't think there's any choice here. You just do that, do that, do that, and hopefully one of them will pay off, and eventually your project will get more broadly known. Um,
Was there an example of a meetup or a conference where you found it particularly worth going, or a trip worth having or worth doing?
Uh, I don't know if there's anyone I could call out specifically, but I think generally a lot of the benefit from these events, apart from the direct like marketing and publicity, is the feedback you get from people in person, which is usually a lot more than the feedback you get when you post
Mm-hmm.
something online. Like posting online is often like shouting into the void. You post something and nothing happens. 10,000 people read it and no one says anything to you.
Right.
Whereas you go to meetup, maybe instead of 10,000 people being there, you have 10 people there. But after that, five people come and talk to you, and you can learn about what they like, what they didn't, what resonated, what didn't resonate with them, what their limitations and constraints are, and all sorts of things that you wouldn't do if you're just posting on GitHub and Twitter.
Right.
Um, so I think, for example, one thing that came up during this tour was it would be nice to have a good command line autocomplete support for the mill build tool.
Mm-hmm.
And it's not difficult. It's kind of out of my area of expertise, but with a bit of AI agent help and some other stuff, we managed to bang something out in about a day or two. And now we have this purely because I talk to people at conferences and they're like, hey, it would be nice if you didn't have to type out these commands every time and you could just autocomplete it because the tool already knows what you want to do.
That's so nice. I wanted to ask for examples of the kind of feedback that you found valuable, but you already answered that, and I think it is quite valuable, especially if it comes from people, from like real people, rather than um, just random replies on Twitter or whatever, because you don't know how important that feedback or that comment is to the person who wrote it. When you see a comment on Twitter, for example, you don't really know how much effort or um, how important that subject or that idea is to the person who wrote that, and so you don't really get real feedback unless it's in mass, which rarely happens. And
Yeah,
on
I mean, there's this thing called the dead internet theory where the internet's full of bots and spam and you can't really reach real people. And I think to some extent that's happened. Like y- Twitter, Reddit, to some extent, even Hacker News and others, they're not quite what they used to be 10, 15 years ago. There's definitely a lot more marketing, a lot more content marketing, a lot more bots. And I think people know that, and many people have kind of turned off these sources because it's no fun going on Twitter to argue with bots, even though like Twitter thinks it can increase the engagement. So I think compared to 10 years ago, the ability to reach people via these online channels is definitely kind of gone down a bit. I think people are actively knowing that social media is not particularly good for your mental health in many cases. And so if you want to reach these people, well, there aren't that many options. You can't reach them on Twitter, you can't reach them on Reddit, you can't reach them on whatever alternatives you have. So maybe you can reach them in person.
Mhm.
And that's what I've been trying to do.
Awesome. Um, what's your current process for working with Mill? Mill is your main project right now. This is the place where you
That's
spend
right.
the most time and effort, right? What's your current
That's right.
process of working with Mill at the moment?
Yeah, so the current process is I've been going on kind of evangelism trips maybe once a quarter. So
Mm-hmm.
this year I've done four. I've done four, maybe I have one more coming up in November. And in between that, that gives me maybe like 8 to 10 weeks in between each trip to actually work on the project. So these trips, usually when I go on them, I get lots of useful feedback. And when I come back, I'll spend the next 8 to 10 weeks implementing all this stuff before the next trip. So I work from home, so there's a home office.
Mm-hmm.
And yeah, so it's a build tool for JVM for Java, Scala, Kotlin. So I use it to build itself. Use IntelliJ, all the standard JVM JVM toolchain, JProfiler. Uh, yeah, and basically pull requests going online to GitHub and merging them once the CI is green. So I've been trying to get some people to help out as well. That's been varying successful to varying degrees.
Mm-hmm.
So I put up some bounties that's gotten a lot of work done for relatively cheap. But not everything can be done as a bounty. I've also got managed to find some people to do some part-time work,
Mm-hmm.
maybe some short duration, some longer duration, like 1 or 2 months efforts to implement particular things. And that's been also great at helping fill the void of areas that I don't have expertise, but other people may have. For
Understood.
example, someone's helping implement Spring Boot support in Mill. I'm not a Spring Boot expert,
Mm-hmm.
but other people who have used Spring Boot in the past will be more able to figure out what's necessary, what's missing, and
Mm-hmm.
what the people using Spring Boot expect. Uh,
That's very interesting. So you're widening the scope from Mill, right? But to target multiple JVM languages and multiple mini ecosystems within the JVM languages. If you're talking about Spring Boot in particular, that's a niche within the Java ecosystem. Um,
That's right. Yeah. So in Mill was started 7 years ago, almost 8 years ago now, and it started off as a Scala project for Scala, as a Scala
mhm,
build tool for other Scala projects. But what I found more recently is that there's, I think, a lot of room for Mill in the broader JVM kind of community. In that, the JVM does have some good build tools like Maven or Gradle, but I don't think everyone is totally in love with these tools. They are old, they have a lot of legacy. They are pretty good, but I think there's probably room for kind of newer ideas or newer approaches to this build tool problem. So I've been hoping that maybe if I can get uh, Java or Kotlin people to use Mill, that's another big kind of target market that's will allow the project to grow further from where it is now.
how do you define success for Mill? What would be successful in your eyes?
Uh, I think if I can get, say, majority of Scala folks using it and maybe 1 to 5% of Java folks using it, that would be very successful. Um, so Scala's small, but I think we have a good chance of getting more people to use in Scala. It is originally a Scala build tool, so a lot of
Hmm.
the affordances and familiarity is there. Java's big, a lot bigger than Scala is, but there's a lot more challenges getting Java people to use it because they're not so familiar with the whole Scala side of things that Mill was traditionally targeted at. So that's a challenge, but the opportunity is also large in that if you can get a lot of Java people using it, it's a huge potential market. So if I think if I can get more than 1% of Java folks using Mill and growing, that would be a good milestone. Um,
And what do you hope to achieve with it? I mean, are you going to build something like a startup or a company around it? What do you hope to? What's your end game for Mill?
I think that's a hope. So many popular open source projects do have startups or companies around them,
Hmm.
whether it's Spark and Databricks, whether it's Sentry, whether it's Confluence and Kafka. Uh, Basically, you name any of the. You look at Bazel, which is the build tool from Google.
Hmm.
Google doesn't support it as much, but there's a bunch of startups kind of sprung up around it because there's many people using it, and therefore there's kind of money to be made.
Hmm.
So the hope for Mill is, well, clearly right now it's pretty small. It's been a side project for the last few years, but if I can make it popular, again, like majority of Scala people using it, maybe more than 1% of Java people using it, then I think there's potentially sustainable business to be made out of this, whether it's via consulting, whether it's via kind of enterprise features, whether it's via supporting cloud infrastructure.
Hmm.
You look at other build tool startups like the Gradle company or the Bazel startups such as Engflow or Aspect or BuildBuddy. That's kind of the model that I'm trying to follow.
Understood. Hmm. And what kind of pains do you hope to alleviate first? What are some of the biggest pains that you've seen in other tools that you hope Mill could solve uniquely or in a far better way than they can?
So perhaps the biggest one is with almost all the existing build tools out there, people are terrified of them. Whether you're Maven or Gradle or SPT, the rule of thumb is never touch a build tool unless there's no way to avoid it.
Hmm.
Because these build tools are confusing. Working with them is extremely error prone. You can easily make mistakes that cause bugs or non-deterministic bugs or non-deterministic like performance problems that don't turn up when you test it, but just slow down everything. So for good reason, people say don't configure your build tool, but that's not really a satisfying outcome because as any project grows, you often do need to configure your build tool. Like you will have some custom this and that, custom code gen, custom pipelines, custom linting and security scanning rules, and so on. So it is kind of a like a lose-lose situation, right? Like if you don't do it, your project can't grow. If you do it, the experience sucks. Customizing a build tool and your project grows, but then your build tool becomes slow and flaky or fragile.
Hmm.
And the hope is that Mill will be able to alleviate that. So, one thing that people who use Mill say is that they love kind of using it and interacting with it, which is something no one says about other build tools because with Mill, it kind of fits into a much more familiar mental model. Like people who use Mill often don't need to learn anything to use it. They already know how the concepts work from their existing experience in object-oriented programming. So unlike Maven or Gradle, where you have to learn about phases and configuration time versus execution time and all that stuff and ordering, in Mill you kind of just write object-oriented code and your build tool does what the code says. I think that's like a quite a big revelation of people who pick it up. It's like, oh, I don't need to become a build tool expert. I know OOP from 20 years ago when I learned Java 101.
Hmm.
And that's all I need to do to make the build tool do what I want and not the other way around where I do what the build tool wants.
Do you think that's I'm trying to gauge how you can build a moat around Mills that the other tools like the Gradle and Maven, and I mean these are probably your main competitors, but potentially
Yes.
Bazel as well. Um, build tools cannot really replicate. So, what would be your unique selling proposition, if that makes any sense? So it's the is it the build as code experience? What is it?
I think the goal is to just improve the ease of use across the board. So the kind of the programming or customization model I mentioned earlier is one of the facets of that. But given the programming model is easier, that means that someone who is working to do other things in Mill can have an easier time doing it than we're doing the same in Bazel or Gradle or Maven,
Hmm.
which means that we should be more performant than the other tools because we have an easier time working on performance improvements than the other tools do. We should have better ID support than the other tools because, again, it's easier to work with Mill and make it fit into what the ID expects. We should be more scalable within other tools because it should be easier to sort out and investigate performance issues in Mill than it would be in a large, for example, Gradle code base. And that's not always the case, but the hope is that given Mill is easier to work with, hopefully we'll be able to use that ease of working with to work with it and improve all the other things that people also care about in their build tool.
Understood.
Um, like performance, for example, Mill is maybe I think the last measure is like 4 to 6 times faster than Maven to compile the same code.
Hmm.
So it's doing the same thing, compiling the same source files to the same Java compiler. We didn't rewrite anything in Rust or anything, but improving the Maven's performance is difficult and fragile, whereas improving Mill's performance is relatively easy. And so we've gone and improved it to quite a large degree.
Interesting. So
Um,
you believe that the performance aspect, which is one of the first things that people ask when investigating a build tool, like how fast can it compile my code, uh, you're you're betting on Maven and Gradle being far slower to adopt or to match your performance.
that's right. They
Okay.
are improving, but I think because Mill is easier to work with for everyone, not just end users, I think it'll be easier for Mill to stay ahead than it would be for Maven or Gradle to catch up.
I read a bunch of Hacker News comments about some of your posts on Mill, and one of the criticisms that I saw on the comments there was that people were reluctant to use Scala as a configuration language, um, because they saw it as an unnecessary hurdle to learn another language to configure your builds. Um,
Mhm.
what is your take on that?
Uh, I think that's all true. And one of the things that we've been working on is a new config only syntax for Mill for simpler projects.
Hmm.
So for many Mill projects, you do not need custom code generators or custom resource pipelines and so on.
Hmm.
So using Scala is kind of overkill, right? Like you can do all sorts of crazy things in your Scala code, but
Right.
most often you don't need to. So we've been working on a YAML config format for people to use in Mill. It maps basically directly to Scala because of the way Mill is very heavily based on JSON serialization already. So every task already has a JSON output, and JSON and YAML are basically identical. And the hope is that for many smaller projects or simpler projects that don't need like deep customization, Mill will be able to provide things like the performance improvement and ID integration and all that without having the end user need to look at this complicated like programmatic build definition. So if you're using Java for a small project, you don't need to go and learn the Scala syntax to go and add Maven dependencies to your small project, for example.
How did you end up
So I think,
picking? Sorry to interrupt. Please go ahead.
yeah,
I'm going to ask the question later.
yeah. So I guess the hope is, I think people are okay to learn Scala if they need to, but the idea for the YAML syntax is for people who don't need the greater power of a full programming language. They don't need to be faced with the complexity and kind of intimidation of having a full programming language in their build config. They can just edit some YAML files, add some lines to the list of dependencies, and everything else will work kind of as it did before.
Hmm. How was the choice of the config language made? Why YAML out of all things?
It's the most popular out there. None of them are
Even though
perfect. There's
there's
YAML,
so
there's
much hate
TOML,
against it.
there's hate against all of them. So if you
That's
pick
fair too.
JSON, JSON 5, TOML, they all have good reasons not to use them. And in the end, I'm not going to make my own config language just for this. So I need to pick something that's already out there. So YAML was the winner.
Understood. I wanted to ask about your experience building things at scale because Mill is obviously inspired by your professional experience with build tools, with
Mhm.
um, automation, with all sorts of things related to that sphere. Um, why did you, or why did Databricks use Scala not just for Spark, but also for orchestrating these large clusters and for automation?
Yeah, I mean, Databricks used Scala because it came out of the Berkeley lab where lots of people like was Scala fans. I think
Right.
that was the long and short of it. So they aren't particularly sophisticated in their usage. It's kind of like a Java plus plus
Mm-hmm.
Kotlin-ish level of Scala. But it works well enough, and I think they've been happily using it for the last 15 years or so.
Mm-hmm.
Um, yeah, I mean, back in when they started the projects, like 2014, 2013 era, you must realize that back then there weren't so many options. Like
Right.
you didn't really have Kotlin. You didn't, I think Swift had just come out. TypeScript didn't exist yet. Uh, Python didn't have types or multi-threading or all of the nice things that they have today. Java didn't have lambdas, I think, or maybe had just gotten lambdas, but didn't have all the other nice things that Java has today in Java 25. So Scala, despite its weaknesses back then, was quite a reasonable choice. Although again, it was somewhat arbitrary. Like basically every project out of that lab in Berkeley was built on Scala because that lab was like a bunch of Scala folks.
Right.
Just like imagine the startups that come out of EPFL in Switzerland would also have lots of Scala for the same reason.
Yeah.
Yeah.
I would anticipate that. Can you give me an example of of a situation at Databricks where Scala is used for really good scalability and where Scala is really powerful?
Um, so I left last June, so I can't speak to what they're doing today, but I think a lot of the value of Scala at Databricks has been that it is usable across the entire stack.
Mm-hmm.
So it's not that Scala can do one thing better than everyone else, but it's the fact that your command line tools can be written in Scala, for example, using the OSLib or request libraries or upickle and so on. Your backend services can be written in Scala because the performance and tag checking and all that and maintainability is good enough. Your distributed systems and the user-facing API can be written in Scala because you can make the syntax easy enough for people to learn and use. There's definitely some reasons where you don't want it. For example, there's a distinct push towards lower complexity user-facing APIs. So, for example, from Scala going instead of having your Spark API be in Scala, you can have it be in Python where more people are familiar.
Right.
Instead of Python, you can have it be in SQL where even more people are familiar. And now with the recent AI LLMs, instead of SQL, your user-facing API can be in English, which is even better.
Mm-hmm.
So there's definitely been a push away from Scala to try and simplify things because, again, many people don't need the full power of this full programming language to just run some kind of like summary statistics on their data set. But just within Databricks, being able to use Scala just everywhere, I think is a big plus. Like it's performant enough, you don't worry about performance too much. It's safe enough with type checking and so on. You don't need to worry about scale a bit about kind of bugs and whatnot. You can deploy it, has good tooling with the JVM, it's concise enough to use for things like command line tools, so you don't need to write some things in Python and some things in Go and some things in like let's say like C++. Um, so it's a pretty good general purpose language, although as Databricks as a company has grown, the thing people have specialized, and so there have been more kind of specialized teams working in other languages
Mm-hmm.
because the need for specialization is there. Like sometimes you do want your extremely high performance stuff in C++, and you cannot use the JVMs, or sometimes you do want to integrate with some particular third-party API that's only exposed in Go, and you need to use the Go language for that. So I think that's expected as a company grew, but to go from like 1 to 1,000 people, I think Scala was a pretty good general purpose language for more or less everything.
That's very nice. I wanted to ask about the onboarding process because Scala has, um, I think, unfortunately, and in my opinion, undeservedly, a reputation for being too complex and hard to pick up. But as far as I've read, and you can't believe everything you read on the internet, so please fact check me on that. Um, you have, or Databricks had, a very quick onboarding process for new folks writing Scala, that they would be able to ship code very, very quickly within days. How was that? Do you have any knowledge about the onboarding process or what made people productive with Scala so quickly?
It was a fact that we didn't use any of the popular Scala frameworks that add a
Mm-hmm.
lot of complexity. So we did not use Akka, they did not use CATS, they did not use Scala Z, did not use ZIO, they did not use a lot of the other kind of more advanced type level stuff or
Mm-hmm.
kind of meta programming stuff. So when you take away all that stuff, you realize that Scala is like Python with 100x better performance and a great deployment kind of deployment and operational story, and maybe some curly braces. So there was no special onboarding process. People came in the code base, and without all the advanced FP or advanced async actor stuff, Scala code is really no different from most other programming languages out there. And there was no Scala like school. You just came in and
Mm-hmm.
you expected to start writing code, and you know how if statements and method calls and functions and classes work. So, well, that's all we have here as well. Um,
If Databricks were to start again today, would Scala still be a good choice for the entire stack?
I think I think it's a good choice, but now there are many other good choices as well. Kotlin is quite popular now. I think it does a lot of the same things well, has its own problems sometimes, but also has its own benefits in other ways.
Mm-hmm.
TypeScript is now a very viable alternative if you want a typed language for your backend. Now, in 2014, you couldn't really use type Node.js reliably on the backend, but now it's very standard.
Mm-hmm.
Uh, and Go is a good competitor now. Uh, it's a very different aesthetic, but it's also very popular and a possible choice. So I think if Scala wants to remain relevant, it needs to keep improving. Like Scala has gotten better since 2015, but so has everyone else.
Mm-hmm.
So Scala can't just sit there and say, "Oh, we are always going to be the advanced language," because if it doesn't keep improving, soon it's going to be the backwards language, as other languages copy all the good features and more.
Yep. This is something that I noticed as well, and uh, I think we both try to speak about it within the Scala community about the fact that Scala needs to continue being a better language. What do you think would be some killer features or killer, um, okay, not killer features. What would you think would be, uh, let's say, an asymmetric contribution to the Scala language and or foundational ecosystem so that it has a disproportionate positive impact on how Scala is going to look like or how Scala is perceived? I mean, what is the most bang for the buck kind of improvement you would see in Scala in order to continue being the better language?
I mean, Scala overall as a platform, the biggest thing is actually not language related. It would be compiler performance and ID support quality.
Right.
Those are the big unsexy things that no one wants to work on, but are very important for people's day-to-day productivity. So I know IntelliJ and Metals are catching up, but they're still not as good as you'd hope for,
Mm-hmm.
given what you'd expect from how it supports Java or TypeScript or others. Um, so those I think are the biggest things. In terms of the language, maybe even before language, the other one is maybe the library ecosystem,
Mm-hmm.
where if you have a new grad, let's say 19-year-old fresh out of college, maybe they graduated early or something, who knows, uh, and they want to make a website for their school project, what's the path for them to do so? They're not going to learn kind of reactive streams and like event sourcing. They are not going to be able to learn IO monads and category theory and using Clays-Lees in their web
Mm-hmm.
server definition. So without these new people, there won't be any new blood coming in. So we do need some easier stack for people using Scala, at least to try and allow those who are already somewhat interested on the margin to have an easier time onboarding and easier time getting to something useful than the more advanced frameworks that are more popular today and in the past.
What would you say would be the biggest components of that approach? What would you I mean, if you were to design like um, a foundational stack for somebody new who knew how to code and wanted to build something useful, like build a website, build a tool for whatever, build a script, build something valuable. Not necessarily a startup, but maybe potentially. I mean, an MVP can be done like I mean, a week or several weeks. Uh, what would be some of the major components that you would see a foundational stack that would deliver well on that promise?
I don't think there's one big component, but for example, if you look at the JetBrains or Stack Overflow surveys, what people use Python for, one of the things that's very notable is just how diverse the usage is. So
Mm.
look at Scala, and basically everyone's writing only compilers or high performance backend web services. That's it.
Mm-hmm.
In Python, you do have people writing backend web services. You have people doing kind of low scale prototypes. You have people doing kind of DevOps automation. You have people doing machine learning. You have people doing kind of image processing and other random things. You have people doing reverse engineering with Python. Uh, so I don't think there's one big thing to say, but basically we need to find a small number of things and try to improve the path to make it easier to get started. Like maybe we need a way for people to onboard and write a website without learning like category theory or
Mm-hmm.
actors or futures. Maybe we need a way for people to kind of set up a build pipeline without having to tear your hair out of all these like kind of crazy operators or data model. Uh, so is that kind of thing that I don't think there's going to be one silver bullet, but basically you need as many lead bullets as you can to kind of defeat the problem and make Scala easy enough language for people to pick up regardless of what they're doing. So I think mill is one part of it. Like the Scala build tool SVT has traditionally been, I think, a big pain point for people learning Scala.
Mm-hmm.
And I think if we can get people to use mill, then that's that problem solved forever. Like mill is not simple, but it's easier to use, easier to learn, and generally not quite as scary as SVT is or used to be. Beyond that, like you need some kind of web service framework, maybe.
Mm-hmm.
I have my own project, micro framework Cask, but it's too small to really be a viable long-term stack for people.
Mm-hmm.
So you need more than that, right? You don't just need routing. You also need authorization, authentication, cloud API integrations, maybe open API generation. It's kind of a long list of things that people will need to do and we need to kind of smoothen that path for a few things. And hopefully that will help people onboard to a Scala language.
Speaking of uh, companies that, I mean, most of the um, industry adoption of Scala is mostly companies rather than individuals. Um, and companies are very seldom convinced to pick a niche language. It's not the 2015s anymore where people would just pick up Scala to build a Twitter or something and then stick with it and build a stack of libraries, and probably nobody has time for that anymore, even with AIs and stuff. So I wanted to ask about the reluctance of companies to pick up Scala, uh, and what it would take to sort that out. And from your experience at Databricks, I mean, Databricks uh, is kind of an outlier because they already had Scala at their core. They already were using it across the entire stack. But I still think that your Databricks experience can still speak to this question, which is what would be some checkboxes that the Scala ecosystem would need to check to make a company comfortable adopting Scala for its, let's say, important code or a critical toolkit, or for example, a critical flow or critical backend or a critical service or something like that. What would be some of the main components that you think would make a company comfortable picking up Scala?
I think the way you look at it is the big companies of tomorrow are the small companies or the individuals of today.
Mm-hmm.
So you're not going to be able to go to existing big company and say, hey, rewrite your stack in a new language. That's just never going to happen.
Right.
But if your language is sufficiently easy to use and has sufficiently productive to get started with for one person, then maybe they'll become known and you'll get a lot of these one persons using it. And if you're lucky, some of these one persons will then be 10 people in a few years and 1,000 people in 10 years.
Mm-hmm. Right.
So I think it really comes down to, is it easy to get started and do something useful?
Mm-hmm.
And in the past, Scala has been ferociously bad at that. So it's honestly quite amazing that Databricks on Twitter managed to get Scala working as well as they did in 2014, 2015. Because I tried using Scala for production use cases when I was at Dropbox back in the day, and it was just a total disaster. And the fact that some companies managed to make it work is a miracle, but we can't
Right.
rely on miracles. If we want to allow Scala to grow, it needs to be easier and reproducible, that a newbie can pick up Scala and do something that newbies want to do without having to learn all sorts of crazy esoteric concepts. For example, like I wanted to send push notifications to my website. I need to learn about enumeratees using the Play framework.
Yeah.
And then you kind of Google enumeratee, and Google's like, there's no such thing as an enumeratee. What are you talking about?
Yeah.
And then yeah, that's that. So that's a kind of blocker that most people would have given up on. And the fact that kept with Scala and ended up having to write my entire own web stack is unusual. But and can't rely on that. We need to have something that's easy and reproducible, and any newbie can pick it up, not learn too much, and be able to do something cool and useful with the language.
Do you have a favorite library or tool that you love in other languages or that you find exciting in other ecosystems that you wish existed in Scala?
Uh, I think maybe the biggest thing I miss from other languages is IDE support from coming from Java.
Mm-hmm.
Like Java is a kind of clunky, verbose language, so it's kind of annoying to navigate around. But the IDE just working
Mm-hmm.
is amazing to me. So that's what I miss most in Scala, where IntelliJ or VS Code will get into funny states or get stuck and you have to restart it and so on.
Mm-hmm.
So I mean, different people have different preferences, but like one of the reasons I ended up using Scala was because it had better IDE support than a lot of the other niche languages out back in the day. This
Right.
was in 2012, 2013.
Mm-hmm.
And ID support's gotten better, but still isn't as good as you'd hope for, given that how much information the typed compile language has to give the IDE.
Yep.
There are many reasons for that, but hopefully it'll get better over the next few months and years.
Hmm.
Um,
What are some misconceptions about Scala that you think people are getting wrong?
I mean, the biggest one is the idea that you need async for performance.
Hmm.
That's just wrong. I mean, YouTube is built on Python, Stripe is built on Ruby on Rails, or so is GitHub.
Hmm.
Yeah, you're not more high scalability than GitHub or Stripe or YouTube. And this whole async performance thing is honestly very strange. Like, you know what? No other ecosystem does this almost, except maybe JavaScript because you have no choice without threading. But if you ask about async on, for example, I saw a post recently on the Java subreddit, like, should you use async? And the answer is overwhelmingly no, you should not, because you don't need it and it
Hmm.
adds a lot of complexity to your code. And somehow I come to Scala and everyone's using async and it does add a lot of complexity to their code. And now you're talking about async back pressure and async streams and all this crazy stuff that honestly, if you're not the next like Netflix, you don't care about at all. Like most systems that people make probably get more closer to one request per hour than the number you require to get that makes async useful.
Right.
Um, I think that doesn't matter whether you're in the Akka land or whether you're in the cats type level land or whether in the ZIO land. That's the biggest like crazy thing about the Scala ecosystem that makes Scala hard to learn and hard to use. Like if you take away async, just spawn a few more threads, it's fine. Especially now with Java 21, you can spawn a few million more threads, it's also fine. Then so much more so much of the complexity just vanishes.
That's a very interesting take. There was a viral tweet, if I remember correctly. It said something like, "Guys, I have 5 concurrent users. I should probably now switch to Kubernetes," which I think describes the vibe of pushing async. I mean, Kubernetes is a different thing, but it's probably the same kind of idea that people take up async and streams and reactive stuff too quickly before they can ever
Yeah.
reach the scale that requires that sort of thing.
I mean, if anything, I would say that Scala as a community is probably one of the worst communities at doing async stuff in whole programming ecosystem. Like the tools are better, but you use them so much more when they're not necessary that the final amount of suffering probably ends up being much larger than someone using Spring Boot and spawning 2 extra containers
Right.
to handle the extra load. Like, it costs a bit of money, but it's not the end of the world.
I wanted to um, ask to go back to your Databricks experience a bit, and I wanted to ask about your experience switching roles. So you were an IC, like an individual contributor. Then you switched to tech lead. Then you switched to manager. Then you went back to IC. How did that process go? And especially while working remotely.
Uh, it was very difficult. I was the tech lead because there was no one else who could be it for our team. Once we hired another person to be a tech lead, I promptly gave him the responsibility and I ran off to be IC again. Being a manager requires a lot of face time, basically, and it's very hard to get face time when you're 18 hours or 8 hours in a different time zone. So at one point, I was the tech lead manager for a team that was spread across Western US and Western Europe, and me
Hmm.
in Singapore. And we made it work, but it wasn't great. Many 6 a.m. meetings after previous midnight meetings. The sleep schedule was all hectic and crazy. So we made it work for a while, but once there was someone in a better time zone, then I promptly got him to be the manager and ran off on paternity leave.
Right.
Um, yeah. So it definitely can be done, but it's not easy, and I think most people won't be able to do it. Like, people talk about remote a lot, but honestly, I think most people are not equipped to work remotely from a mental, emotional perspective. Like, it takes so much more energy to keep yourself focused remotely than in person. Like, when the TV is there, the couch is there, the bed is there, and there's no one looking over your shoulder, it does make it easier to slack off and end up watching YouTube videos or just being not unproductive.
Hmm.
So I know there's a lot of like hoo-ha about, oh, we need to go back to the office, but honestly, I found my office time a lot more productive than my remote time. And the only reason I'm so far remote is for family reasons, because family is based in Singapore and I want to be close to them.
Right. What do you think? I mean, besides the time zone differences, and obviously that makes things difficult to schedule in terms of calendars and whatnot. What do you think was a difficult part of being a tech lead or a manager, which then prompted you to switch back to IC? Because you're an engineer foundationally.
Mhm.
What was the difficult part of? I mean, what parts did you find difficult of being a tech lead or a manager, given your foundation as a software engineer?
I think it again just comes down to scheduling. I guess the
Mm-hmm.
fundamental problem is that as a company grew, there were just more and more stakeholders for any decision, project, event, or meeting.
Mm-hmm.
And when the company was smaller, I needed to coordinate with five guys to do something. I could schedule enough time to get on board with five guys and get everyone on board together.
Right.
Whereas the company got bigger, I need to get scheduled and get 20 or 30 guys on board. Then that becomes much more difficult. So I mean, I guess the worst thing you can do in any like discussion is not be present. And
Mm-hmm.
as a person based in Singapore, I was not present a lot. So, it doesn't matter how good a Google Doc you write, if you're not there in the meeting defending it, or not there arguing it, or not chatting with your boss over lunch, it's very hard to kind of move things forward
Mm-hmm.
and keep things like under control. So just naturally, as initially I just was a manager and lead because no one else could do it, and the team was small enough that it was workable. But as the company grew and the teams grew and coordination costs increased, it was very quickly obvious that doing this from Singapore wasn't workable. Uh, so we tried a bunch of things, right? We tried different time zones, tried different schedules, tried different styles of projects. But I think in the end, we decided we'd be better going back to being an IC, especially once we found other people to take on the leadership responsibilities.
Understood. So it's a scheduling, synchronization, and communication problem, which,
Yeah.
uh, if I'm understanding correctly from you, it requires a lot of mental burden and mental overhead just to make work, especially in a remote setting. Am I getting this right?
Yeah. If I was in person, I probably would have had a different path,
Yeah.
but that's not the world we live in.
I asked this question because I mean, not all programmers, but some programmers dream about becoming leads and managers so that they can get away from code, so that they can have bigger impact and manage bigger and bigger teams and whatnot. And I asked this question just to uh, get your take on it and get your personal experience, because it's not all roses and butterflies. It's a lot of mental overhead, and a lot of times you wish you just got back to coding because it's something that flows naturally, especially if you grow up as a software engineer. It it's just fits well with the mental model. Um,
Yeah, it's a different job. Just because you're a coder doesn't mean you'll be good at it. Just because it pays more doesn't mean you'll be happy being paid more. It might not even pay more depending what kind of salary structures your company has. Um, but like I told you, I gave someone else a job of being a manager when I went on paternity leave.
mhm.
And after a year or two, he decided he wanted to go back to coding as well.
I understand.
So he was a manager for a year or two and then nope, like not happy with it. So he went back to coding and eventually found a different manager to take over.
Right. And I
Yeah.
mean, it's a common, it's something that I hear about a lot to from programmers that I know who got into lead and manager roles, and then they got back to programming because they just feel better and are more skilled and can indeed have more impact with using their skills well in programming. And this is especially true for programmers who got into programming out of vocation, which is what segues me into my next question, which is what got you into programming and how did Scala catch or stick with you?
I got into programming from modding video games. So my first my first coding, so to speak, was modding the user interface of the old like EverQuest MMORPG. So that was specified in XML files. You could edit the XML files and move the UI components around the screen, and that wasn't didn't do anything for the game itself. It was just fun. I could do it.
Hmm.
You could change your health bar from red to white or green or something, and it
Yeah.
was just fun. Yeah. And then I spent a lot of time doing Warcraft 3 custom maps.
Hmm.
So Warcraft 3 is a video game from back in 2001, and it is famous for having such a powerful kind of programming environment, scenario editor or map editor, that several genres of video games came out of Warcraft 3.
Hmm.
So the whole MOBA Dota thing came out
Hmm.
of Warcraft 3 custom scenarios. The whole tower defense thing came out of Warcraft 3 custom scenarios. A whole bunch of other similar games came out of Warcraft 3 custom scenarios. None of my Warcraft 3 custom scenarios were any good. I was just a kid playing around. But it was a lot of fun. And like you could do things like get conditionals, if statements, loops, variables. You can make your orc do things, or
Yeah.
you kill your orc if you walk in a certain area, or spawn more orcs, or
Hmm.
yeah. So back then it was the platform had both a scripting language called Jazz and a UI point and click coding framework where you just like click on the if statement and have boxes. You click on the condition and click on the
Hmm.
then case and else case. So I was not skilled enough to learn Jazz. I was like 10 years old or something, or 12 years old. So I just used a point and click. And then we had a we had a intro to Java programming class in high school or middle school. So
Hmm.
that was like 2000, and that must have been 2003 or so. And that's when I learned my first real programming language and actual programming. Made some video games realized I wouldn't be able to get anyone to play them because this was before the App Store, right? You couldn't just like burn CDs and put them in a shop. Like I was 14 years old.
Yeah.
But it was fun enough to play with and make myself. And that's how I got into programming and went to college and did programming and so on.
And how,
Yeah.
out of all things, how did Scala stick?
Uh, I was playing around with a bunch of different programming languages in college. I mean, part of the point of college, you just try things. And I was trying like programming environments and languages. So we had to learn Python for school. I had to learn PHP for my first internship at Facebook.
Hmm.
I had to learn MATLAB for some other like statistics, economics projects.
Yeah.
Uh, from those, I learned some other things. Like I learned C sharp for for a robotics project where the robot had an SDK that was written in C sharp or C++, and C sharp looked easier. I knew Java from before. I had learned JavaScript for school
Hmm.
or to make websites and stuff. And I tried some other languages I played with F sharp for a while, ended up trying Scala, and that ended up sticking. Um, I mean, they all have their pros and cons. Scala had a bunch of cons, especially back in 2013. As I mentioned, trying to use Scala at production Databricks at Dropbox was a total disaster. But had a lot of fun, had a lot of good stuff to it, and that's why I stuck with it. Um,
What do you think stood out for you that stuck? I have my own reasons for it, but I
yeah.
wanted to have your take on it.
It had the third best IDE experience of any language I knew. So it was only behind C sharp and Java,
Hmm.
but had better experience than Python, JavaScript, C++, PHP, MATLAB, and everything else. And I really like using IDEs, so that's valuable to me. Even F Sharp, which is by Microsoft, didn't have good Visual Studio support, despite being the same company, because the team was focused on C Sharp for the developers. That's one. The other was it's just a very regular language, so to speak. So a lot of things that are different language features in Java or C Sharp or Python are the same language feature in Scala. The biggest one, for example, is the idea of a function call.
Hmm.
So in let's say let's say Java, you have array indexing, you have method calls, you have map.get or list.get, you have factory methods, and factory pattern and all that. Um, and in Scala, all that just falls down to a function call. Like
Yep.
your array indexing is a function call, factories as a function, your map, your list lookups are just it's just a function call. And this made things like a lot more regular in many ways than other languages where you spend a lot of time thinking about these unnecessary kind of differences.
Mm-hmm.
Another example maybe is that in F sharp, they have special syntax for modifying a record. You say curly brace record with key value to modify a record.
Mm-hmm.
And that it works, is very convenient. And Scala, that is a function call of the copy method.
Yep.
You say dot copy and then you pass in the key values and you're done. So I think that was, to me, very nice. And another one was data structure literals, like arrays or lists or maps.
Mm-hmm.
In Scala, that is a function call. In other languages, you have all sorts of syntaxes and stuff for it. Now, there are benefits for having these syntaxes, but the fundamental idea of just so many of these things being boiling down to the same kind of construct and having it be flexible was, I think, quite nice. And it's something that many other languages didn't do well. Like you end up having to learn so many different things, and in the end, they were really kind of the same, just spelled differently. But adds complexity to reading and writing code every day.
Do you think that's still the case?
Uh, I think it's still the case largely, but other languages are catching up. For example, uh, Kotlin constructors no longer need to be called with new.
Mm-hmm.
They now just look just like functions, just like in Scala with case classes or
Mm-hmm.
Scala 3 like constructor syntax. So and I think Swift has very nice support for like array literals and map literals and so on. That's kind of generic and type safe and all that. So it has many of the benefits of Scala's map or list literals, but with better syntax and less mental overhead. So I think it's still true to some extent, but there's no doubt that other languages are catching up, and they'll sooner or later catch up or even go beyond what Scala has today.
What do you think Scala could do to differentiate itself in terms of these languages catching up? So Java and Kotlin took a lot of functional syntax or functional concepts from Scala. I mean, all these records and data classes, Java records, Kotlin data classes. Um, Java started with Lambda syntax in Java 8, but ever since Java went or adopted a far um, far more frequent release cycle, they adopted an increasing number of Scala features, and Kotlin does the same thing. Where do you think Scala can still differentiate itself?
I think one big area is just how well these different things work together.
Mm-hmm.
So one thing about languages like Java and Kotlin or C Sharp is that they have a lot of these features and they do work, but when you put them to when you put these features together, suddenly everything blows up. For example, Java has lambdas. Java has fluent like map filter, reduced like Scala does, which is great. Until the thing in your lambda throws a interrupted exception or IO exception, and
Mm-hmm.
then you need to try catch, throw new runtime exception, wrap the old exception, and it just becomes a huge like mess. Even the different features on their own look great, but together with the other features, it just doesn't work well together.
Mm-hmm.
Um, yeah, so I think uh, I can't speak for the details of Kotlin because I haven't used it as much, but many other languages, these different features don't quite mesh as well as you'd hope they do. Another example maybe is like Python, where Python now has async baked into all the syntax of the language. You have async for, async with, async method call, async this and that.
Mm-hmm.
And it doesn't feel as good as you'd hope for. Like it kind of is its own thing there. You can't really use all these other features because it's in async context, and uh, it doesn't really work as well as like a cohesive language. And I guess it adds a lot more complexity than you'd expect and you'd hope it for it to do so. Um, so I think that if Scala can keep things kind of cohesive then that would really help it stand out versus other languages that have a million different features that don't quite work well together. I mean, Scala has its own things that don't work well together, but I think empirically things work well together more than most other languages, at least from a language perspective,
That's
ignoring
an
the
interesting take.
ecosystem.
That's a very interesting take.
Yeah.
Do you think so? To what degree do you think the new Scala features of capture checking and capability tracking fit into this story, or is that something that you are not going to use in the same style that you don't use Akka or IO monads?
I think those are a neat research project, but I don't think that they are the high order bit in trying to get adoption.
Mm-hmm.
I mean, as you know, like EPFL is research lab, so although they do a lot of like operational and kind of keep the lights on work, a lot of the work has to be more research related, so capture checking is more on that end.
Mm-hmm.
So I think there's a lot of value there, but I don't think it is the thing that is missing from Scala right now. Um, I think it will help somewhat. There'll be cases where it's nice. I have bugs that get caught by capture checking maybe once every 3 months or so. That would get caught by capture checking me once every few months. It may open up future possibilities for the language, but it's a very long-term research bet rather than a kind of execution-based bet.
All right. I wanted to ask about your library ecosystem. Speaking about productivity and operational things, you maintain a big ecosystem of many libraries. How do you manage to maintain them given the fact that they are heavily used and that you also have external contributors?
Um, I think the answer is that most of them are more or less done and do not require much change, if at all.
Okay.
Uh, for example, consider the consider the parsing library, FastParse.
Mm-hmm.
That was written in 2014, I think, maybe 2013. It basically sat there unchanged until 2019 or 2020, and then I spent about like 2 or 3 months rewriting it for some big performance speedups, like maybe 4x better performance. And it's sat there until now. And people use it, people file tickets sometimes, but basically it does what it does, and there's not much to maintain or talk about. And the same can be said of most of the other libraries, like the unit testing library was initially written in 2014 as well. And it only really got maintained this year in 2025, where I went and cleaned up a bunch of stuff that was stuck there, that was kind of out of date or broken for last decade.
Mm-hmm.
So yeah, many of these libraries, because the scope is small, it's not like an endlessly growing thing where it's exploring some big solution space and trying to pivot to become a startup. It's just, it parses JSON and it serializes JSON, and
Mm-hmm.
JSON hasn't changed, and the things you're putting into JSON that haven't really changed. So the library doesn't really need to change that much. And that's how I manage to keep it sustainable. Like every year, maybe I'll spend a few weeks working on one of those libraries, and that's it. So each library gets a turn maybe once every 5 years to a decade. And
Given
yeah.
given the fact that some libraries are still at zero dot, what would it take for you to make them or to freeze them, like make them 1.0, and declare it, I don't know, ready to use or production use or things like that? What would prevent you from doing that?
There's nothing preventing me from doing that. I just haven't paid much attention to them.
Understood.
Yeah.
Do you think it's worth declaring them 1.0 and making them into a standard layer 2 stack of libraries on top of the standard library? I mean, the standard library is baked into the language. You have it ready for you whenever you use Scala. Okay. But uh, make these libraries of yours a sort of go-to stack for non-fancy Scala developers.
I think it's two separate questions. Like whether it's one or not, I don't think people generally care. Like there'll always be some people who nitpick over version numbers, but I think most people do not. In terms of making them a standard stack or semi-standard stack or unofficial stack, I think that's something that we'd like to do.
Mm-hmm.
How to do that is a separate question. But it would be nice if this was a cohesive thing that people could use and kind of use together rather than just as individual bits and pieces.
What do you think is missing?
Um, so one of the big projects right now is we are working on open sourcing my book, Hands-on Scala Programming, and
Mm-hmm.
putting it on the Scala website for free. So I think that would be one of the big missing parts. Like the book has always been the cohesive way to use these libraries together
Mm-hmm.
versus these libraries on documentation, which is how to use a library on its own. And by open sourcing a book, I have the hope that um, this will help people learn to use these libraries together, and they'll learn not just individual libraries, but learn like the style of programming that these libraries entail.
Mm-hmm.
Um, the other thing that's missing maybe is a more fully featured, I guess, API web server stack.
Mm-hmm.
So like Spring Boot, for example, you said it's a niche just now, but it's like a 95% of the Java ecosystem niche.
Right.
It's a huge niche. But let's say you want to take a Java developer, which statistically just means Spring Boot developer, and you want to give them Scala, let them use Scala, what would they use? They probably wouldn't want to use Scala with Spring Boot that doesn't have good integrations. They probably won't be happy using Play or HTTP4S or ZIO HTTP because they have a lot of pretty advanced concepts that won't be familiar to your run-of-the-mill Spring Boot dev.
Mm-hmm.
Um, and even frameworks like my own Cask micro framework is too anemic to really satisfy someone who's used to the rich built-in like libraries of Spring Boot. Like Spring Boot has a way of doing everything. You may not like it, but it has a way, and it's
Mm-hmm.
documented and it's tested, and there's a golden path for you to do everything you want without having to step out into the wilderness. So I think that's something that's missing for Scala, and it's been missing for a decade now. And I think that's one of the big reasons Scala hasn't taken off.
Yep. Maybe we can do something about it.
Yeah.
I wanted to ask about the book because you've self-published the book. You wrote the book, and not just the book. You wrote the renderer for the book. You programmed the book. You wrote a lot of code for it. Um, I wanted to ask about your writing and publishing process. How did that look like in general? And was that tedious for you? I'm asking this because a lot of book authors that I've spoken with um, told me that it was a chore. I mean, they would just like to write the content or write the code snippets and not deal with all the examples and markers, and this is a call out and this is something, and um, render the book nicely. The editing process was also quite gruesome for them, and also the publishing process because the they had to choose between self-publishing, which is an extra effort, or going through a publishing house and get like 5% of the sales. Um, I was wondering how did that process look like for you, and if it was exhausting for you.
I think it was both exhausting, but also a lot of fun.
Mm-hmm.
Um, I mean, the book rendering pipeline is a build pipeline, and it was written in Mill, like because Mill is a build tool that's good at incremental and parallel renders. So, and I guess in general, I like working with these projects and these libraries. So setting up the examples and setting up the pipeline using the same libraries and frameworks that the examples use
Mm-hmm.
is itself, I think, was quite a lot of fun to do so. I mean, it's certainly a lot of work. Like I went through maybe like 10 different physical iterations of the book before I released it,
Mm-hmm.
fixing things like, oh, this green doesn't work well on the printer that they are using because their printer is a bit faded and you can't really see the green, or
Right.
this gray is a bit too dark and needs to be lighter, otherwise it looks weird, or that kind of thing. Or, oh, they accidentally printed 20 extra pages at the front of blank paper. You should tell them to not do that. Um, but yeah, I mean, it's a project and it's a lot of fun. And in the end, I managed to self-publish it, rather than 5%. I think for the physical copies, I think I keep something like 30% of the money because I chose to print in color because color is pretty, but color costs a lot to print. So
Mm-hmm.
the printer gets about a third, then Amazon gets another third, and I get about the last third for physical copies. And then for digital copies, I get like 90% because I just sell it on Gumroad and they take 10.
Mm-hmm.
Uh, yeah, but I mean, fundamentally, writing a book is not much different from writing documentation of any project or writing a informational website. I have a background in web development, so maybe it's a bit out of date by now, but like I don't have any challenge in making things look pretty on a
Mm-hmm.
rectangular outputs. And so in the end, the book was just a website that was print to PDF, and I just use HTML and put everything in the right place because that's what I know
Yep.
how to do. There are definitely other stacks. Like you could use Prince XML, you could use Microsoft Word, but mine was just like literally a website printed to a PDF that they printed on paper.
And it fit very well with the libraries that you're using. So you're using the libraries that you wrote to build the book where you explain the libraries that were used into that book, which is
Yeah, in fact, the example for chapter 10 is writing a small renderer that takes Markdown, turns into HTML, feeds it into the JavaScript playwright library, and prints out PDFs.
yep.
Because like it's a useful thing. I had to do it, so I guess there's at least one use case, and it's quite cool that you can do so, in parallel with caching and all that. So all the examples from the book are basically my work or personal projects.
Mm-hmm.
Like I did write the file synchronizer for work. I did write the distributed system for work. I did write the real-time website. I did write the book publishing type pipeline, uh, which looks about the same as my blog publishing pipeline. And so all of these are real examples. And I think that's why they're valuable. And hopefully by putting them free on the Scala website, other people will be able to learn and do these useful things as well.
Speaking of the book, I'm going to take this opportunity to thank you for being generous with me using the book for my course Scala Projects. Um, I try to condense your examples and build them into some more end-to-end things that people can deploy and use, like a personal website or an AI agent or things like that. And I wanted to thank you for it. The overlap with the book is maybe like 30% or so, but the examples from the book served as a good jumping off point to get people productive and ship something valuable within like 1 or 2 hours. So I do think your book is valuable, and it would be a big value add for the Scala website if you had these real world examples on the documentation so that people can get some real benefit of using Scala, not just the language features. Um,
Mhm.
is there something that you would change in the book today? If you were to rewrite the book, would you change anything?
I mean, we are rewriting the book and we are changing a number of things. So, one example is when the book was written, I didn't have my own SQL library to use, so we use Quill.
Mm-hmm.
Quill is quite good in some ways, but also has a lot of sharp edges in other scenarios. So it was maybe the best at the time, but now that I have my own Scala SQL library, I'll probably use that.
Mm-hmm.
Um,
Quill, I think it's
when the
not
book,
maintained anymore. Yeah.
yeah, the Quill guy is writing Quill for Kotlin now, so he's not no longer doing the Scala Quill project.
Mm-hmm.
Another one is the book heavily leans on Ammonite, both for the REPL as well as for scripts.
Mm-hmm.
So now going forward, we moved most of the Ammonite REPL features into the official Scala REPL that will go out in 3.8.
Mm-hmm.
So your pretty printed output, your control C interruption, your importing of libraries from the REPL, all that's going into official Scala REPL. So we won't need the Ammonite REPL anymore once 3.8 is out as the first approximation.
Mm-hmm.
The other one is scripts, which Ammonite also provided. Now Scala CLI provides them and a lot better.
Mm-hmm.
My own mill build tool, the next release is also going to have scripting support. So we'll likely use that instead of Ammonite. So I think Ammonite was a good at its time, had a lot of experiments that didn't pan out,
Mm-hmm.
but now you're more or less taking the ones that did pan out and kind of making them official rather than having them hang around in some side project that some people use and some people don't.
Nice.
So, Scala CLI works great for scripts. Official Scala REPL should work great for the REPL once the new version of Scala 3.8 is out, hopefully later this year.
I think we all in the Scala community have to appreciate you baking in baking in your best ideas and the best things that were tested in your open source projects and bake them into the core Scala. Are there any other contributions that you are planning to include in the core Scala toolkit?
Uh, I mean, there've been I've had a lot of language features going in.
Mm-hmm.
So like for example, the one that's recently gone in experimental that'll be out in 3.8 is the ability to have multiple stars in your vararg
Mm-hmm.
function call. So you can call a vararg like a list and can have like not just one parameter with a star, but three parameters with a star, and
Mm-hmm.
maybe some other loose parameters in between, and it'll do the obvious thing and combine them for you. That's just quality of life. Um, we have the ability to unroll parameters via an annotation.
Mm-hmm.
So if you want to add a parameter to a function with a default value while preserving binary compatibility, you can add unroll annotation to that parameter,
Mm-hmm.
and it will create a forwarder to allow binary compatibility to be preserved as this parameter is added. And works for case classes as well. So to add a parameter to a case class, as long as it's a default value, you can add unroll it, and your case
Mm-hmm.
class will be binary compatible. Um, One that is probably going in as experimental as well is there's a new syntax. I'm adding a new syntax for triple quoted string literals.
Mm-hmm.
So the old triple quoted string literals are kind of neat, but they also kind of suck, especially compared to other languages which do them better. Like no other language requires pipe dot strip margin dot
Yeah.
replace slash r slash n with slash n dot trim of the top and bottom. Well, some do, but most of them don't. Like if you look at the Java triple quote string literals, they're just better than the Scala triple quote string literals
Mm-hmm.
because they came later and you could learn from Scala's mistakes. So there's a new triple quote string literal for Scala which uses triple single quotes that basically copies the learnings from all the other languages, from C Sharp, from Swift, from Java. Uh, it removes indentation automatically without these pipes and strip margin. It normalizes new lines for you, so your code works the same on Windows and Mac, whereas right
Mm-hmm.
now triple quotes don't. It removes the first and last line for you, so you don't need to worry about like the putting your triple quotes and having something immediately after or calling trim or other annoying things. So that just got accepted in this implementation that hopefully will go in the next few weeks for 3.8.
Mm-hmm.
Yeah, so I think there's a lot of things you can do, and especially now with the AI agents, the barrier to entry has gotten a lot lower for a lot of these core contributions.
Mm-hmm.
Uh, like the triple quoted string literals were largely vibe coded as a start. Like not completely. I had to go fix some bugs at the end because the vibe coding wasn't smart enough to capture like off by one errors in the parser offset and all that stuff. But at the start, it's like, okay, where are the functions you need to modify to add this syntax? Please add it. Oh, it's wrong. Find the bug. Oh, here's a bug. Okay, fix it.
Mm-hmm.
I would say it's like maybe like 70% vibe coded. And that one of the more recent bug fixes I submitted to Scala compiler was just 100% vibe coded one shot. It's here's the bug, fix it. Here it is, it's fixed. Okay, done.
That was
Yeah,
insane.
I was quite impressed. Yeah.
How do
So,
you
but
see?
these are things that would have taken days or weeks to do before because I'm not familiar with this code base, and you have your AI bot go and dig through the whole thing and find the place to make the change. It's really makes it feasible where previously it was not.
How do you vet the code submitted by the AI, especially
Same
in a
as
code
any,
base that you're not familiar with?
I mean, same as any other code, right? You code review it yourself, and someone who is familiar with it should code review it as well.
Mm-hmm.
So there's no shortcut. In the end, you still need the verification, and as you know, verifying code is often as or more difficult than writing the code to begin with. So you still need to verify it.
Mm-hmm.
But in some cases, writing the code itself is already very difficult in the unfamiliar code base, and the AI makes that part a lot easier.
Mm-hmm.
Um, AI can also write tests for you. Sometimes testing can be very tedious, although straightforward, and it can be much easier to scan tests and see that they do the right thing versus having to write every single test case yourself and copy pasting the output you printed to the command line and making sure it's the same.
Mm-hmm.
Yeah.
How do you see yourself as an engineer now that AIs are writing an increasing amount of code, or that AI generated code is in increasing proportion?
Uh, I think you just move up the stack, right? So in the old days, your computer was a middle-aged woman sitting in a room doing arithmetic on paper, and
Mm-hmm.
there'd be one guy at the front of the room, and the different people in the room would do the same math, submit it to one guy at the front, and he would check that the answer's the same. If not, they'd find the bug on
Mm-hmm.
paper and submit it again. That's how NASA sent rockets to the moon by computers, which are people doing math.
Mm-hmm.
And then there were computers that did math for you, and someone needed to memorize how to program these computers. And your programmer or computer was the guy who had memorized the whole specification for how the computer worked and could do it. And then Google came about, and you no longer need to memorize the specification. You could look it up on the fly. And so now the computer is the guy who can find the thing to do what he wants on Google, maybe, or on Stack Overflow, or so on, and make the computer do what they want. So where previously writing a word, writing a spelling check corrector was like the smartest person in the world could maybe do it. Now
Mm-hmm.
writing a spelling checker is something that you do in a 30-minute job interview.
Mm-hmm.
And then with the AI, it just goes up the stack further. So your individual is now like your human is now like a tech lead or manager. So you have the agents doing stuff for you. Agents get things wrong. Agents don't verify. Agents get lazy or lie to you. Agents do all the things that humans do. But agents are also creative and can kind of do fuzzy reasoning also like humans can do. So you're now as a human controlling these agents, you go and you need to make the agents do something useful, which is honestly not that different from having a bunch of interns and making them do something useful, except agents are usually cheaper than interns.
Right.
They don't need to feed them. But I think as a field, you're just moving up the stack, and it's not new with AI. Like in the past, you needed a 100-person team to make a simple program, and now you do it in a 10-minute interview. But the requirements have gone up, expectations have gone up. You're doing a lot more interesting things rather than doing the same thing fast. Rather than just doing the same thing and then stopping, you have more things you want to do because it's so much easier. So I don't think there's going to be a problem with jobs, at least not in the long term. In the short term, there'll definitely need some retraining. People need to learn the new tools. Uh, but it's like someone refusing to use Google, right? Like that's just silly.
Right.
But you can imagine back in the day, like the guy who had memorized the C++ specification may be a bit, a bit intimidated by all these new people who can use it without having to spend a year memorizing it. Or the guys driving taxis may be intimidated by the new guys using GPSs rather than spending 5 years memorizing the London road network.
Right.
So again, now we have agents. They do a lot of stuff. They're cheap, and hopefully we'll find something we can for humans to do that's valuable using these agents to do more than they could before.
How are you using AIs? Are you using a single one, or are you delegating to multiple agents doing things and then reviewing everything, putting them in sync, that sort of thing?
I won't say that my usage is particularly advanced. I pay for ChatGPT Pro, whatever they call it, like $20 a month. It, as a first approximation, replaces Google for a lot of queer questions.
Yeah.
Um, when ChatGPT is down, I go use Gemini and it does the same thing.
Hmm.
Honestly can't tell the difference. Um, for coding, I've been using Claude, which runs in the command line.
Yeah.
There are a lot of problems with it, but it generally does pretty good work. And although it does require significant supervision, so it is in many ways like supervising an intern. It'll propose something, and you'll immediately be able to tell it, oh, no, that's the wrong way to do it. You'll use the wrong way to run tests, and tell it that, oh, that way is currently broken. Look at this random post on Scala contributors. This is other way that you have to use now until the guy fixes the previous way.
Mm-hmm.
Um, so it's honestly not that different if anyone's ever managed an intern using these AIs to be productive. Like it's not magic, but in many ways it's very handy and it's very convenient.
I wanted to ask about the fun in programming because managing interns or managing an agent and correcting errors every minute or every 2 minutes or every whatever cycle the AI has in producing code isn't as fun as thinking your code and organizing things the way that you like and using the skills that you've acquired to write elegant code and things like that. So there may be a danger in removing the fun in programming. How do you keep that?
I guess it depends on what you find fun, which is different from different people.
Mm-hmm. What do you
Um,
find fun?
One thing I find fun that most people don't is I enjoy taking half-broken code and fixing it.
Mm-hmm. Okay.
So like when I was at Databricks, I love it when my colleagues give me a half-baked pull request.
Mm-hmm.
It's like, okay, well, it's a complete mess because it's half baked. It's obviously not tested. It obviously also doesn't work, but the ideas are there and wrangling it into something that works. I find that honestly quite fun. It's like legacy code, but it was just written yesterday. But it's just as half baked and untested as any other legacy code you'd find out in a while.
Has
Um,
has that
I
always been
think
the
a lot.
case with half baked code when you probably taught yourself programming and modding and things not working and things like that? Was that always fun, or did you
Uh,
develop that in any way?
no, you need to be good enough to be able to do it without too much suffering.
Mm-hmm.
So honestly, it probably took me at least 5 years in industry after graduation before I could do it effectively.
Mm-hmm.
Because initially, like for example, you're in school, like a single Python function without the type signature will defeat me.
Mm-hmm.
Like this, I can't figure it out. Or but as you get better, as you learn the ways to manage it, you get this. It becomes from something that's painful to something that's challenging but tractable. Uh, and you understand your colleagues. You know what the half-baked code is trying to do just by looking at it, even though they didn't tell you, and you can kind of work into something workable. And that's similar to what I do with my own code, like because my own code often starts off half-baked. In fact, almost always starts off half-baked. And then just to get something working at all, and then you hopefully can get into something that works nicely or works well or works performantly or whatever. And so it's not that different from taking the code that my Claude AI agent spat out that's half-baked and broken and subtly broken, obviously broken in different ways, and wrangling into something that I'm happy with. So I think that the actual writing of the code is not so much the fun part. The fun part is deeply understanding what the code is trying to do, what problems it's trying to solve, and how the code solves it.
Mm-hmm.
And that does not go away just because you use the AI. Like you use the AI and you don't do that, then your code is just gonna be broken or buggy or both. And so you still have to do that. And it's still quite fun trying to figure out, okay, what did it try to do? What does it need to do? Is it doing what it needs to do? No, why is it not doing what it needs to do? And you debug it and eventually find, oh, there's an off by one error in the Alexa that the AI didn't realize because of course it didn't. Like intern wouldn't have realized either. And but I know because I'm more experienced in AI is so I can fix it.
Yeah, I tend to agree because the uh, the code that you write is you cannot really think the entire thing from scratch and have it as a moment of enlightenment and then you write the code perfectly from the first go. You have a lot of iteration and you have to also be able to fix your own code and deal with that particular struggle. And the AI probably speeds up the first part, but then the thinking is done in the latter part when you truly understand what the code is trying to do. And only when you've done that good understanding and have a good explanation for the thing that you want to produce in the world with your code, that's when the coding is actually going to take place. Because I tell people, I mean, some of my own students are asking me about jobs and AIs and whatever. And the reason why programmers are not going to go away anytime soon is because you still have to do the deep thinking and the good understanding for what the product or what the tool is going to do, the coding or the typing or the lines, the text is only it has never been the bottleneck. It's not the issue about the text. It's always been the issue about the good thinking and the good understanding of what that thing is trying to do.
Yeah. Yeah, I mean, it's not to say that you should always use AIs, especially when learning. It's good to go through things yourself, just like how in middle school you're made to do math without calculators.
Hmm.
Not because calculators are bad, but because it's good to understand it. Then when you have the tool, you know how to wield the tool more effectively rather than just as a black box.
Right.
I've heard some people say that when doing a programming book or reading a programming book, you should type out every example without copy and paste. And
Hmm.
obviously, you're not going to avoid using copy paste in production systems, but when you're learning, there are these things you do to learn, and then when you have the more powerful tool later, you can wield it effectively rather than being like beholden to it as a kind of mystery or oracle.
It's one of the reasons why my own courses are follow along because even though I mean, ever since ChatGPT came about in 2022, so for the last like almost 3 years now, I still had my my programming courses in the same style, even though AIs can very easily generate everything that I write, because there is no substitute for writing things yourself and testing things yourself and really understanding things on your own code that you put together. So yeah, I tend to agree with this statement, and I think this would be a good place to wrap up. Is there any advice or any message that you would like to send to my audience, who are mostly Scala developers? So if you could send a message to um, the people that are listening or watching this, what would that be?
Uh, I think the main thing is that lots of people talk about whether Scala is going up or going down or whatever, and I
Mm-hmm.
think the important thing is not so much where Scala is going on its own, because Scala only goes as far as the people using it push it. So the real question is like, as individuals who like Scala, what are you doing to do something cool with Scala that you can show off and be proud that I did something with the language that I may have not been able to do with other languages, or and I can do this because of Scala. So in the past, that's why Scala got popular. Like Twitter became stable after all the fail whales because they migrated from Ruby to Scala.
Mm-hmm.
Spark could do distributed cluster compute because of Scala syntax and Scala lambdas and whatnot. But that was 10 years ago. So anyone who likes Scala now, the question is Scala going up or down? Like, what's the future of the language? But as individuals, you are the future of the language. And it's up to us or you to figure out if you can do something that makes the language really valuable.
I think that's an excellent message to wrap up this conversation. Howie, it's been a pleasure. Thank you so much for making the time. We might do a round two at some point, but it's been a pleasure to have you. And I think the listeners and watchers of this conversation got some interesting and valuable insights out of this. It's been a pleasure. Thank you so much for making the time.
Thanks for having me.